Hello everyone, welcome back to another video. Today we will be doing another Leetcode problem. And today's problem is Leetcode problem 5, longest palindromic substring. This is a medium rated problem and it reads, given a string S, return the longest palindromic substring in S. So first let's just quickly define what a palindrome is. It's just any string which reads the same exact way it does backwards. So if we were to take ABA here, reverse it, get ABA, see, it stays the same. Let's look at a different example which isn't a palindrome, BAA. We reverse it, and that gives us AAB. So one is and one is, oops, I got them mixed up. One is and one is not. That's all it is. And all this problem is asking is, what is the longest palindrome that we can find within any substring that they give us? Now let's look at this example that I created. ABA XYZZ. Now, how do we check for a palindrome? Well, let's say we are checking around this letter B. This will be the center of our palindrome. And then from there, we will check the letters around it. Is A and A the same? Yes. So we do have a palindrome, and from there we would extend outwards to the next letters. Are they the same? Now if they are not the same, or if we hit the border, then we stop, and the previous substring is actually our longest palindromic substring. Now what's another way for us to, what about, this is for a odd number of letters. How about this substring right here? YZZY. Well, we don't really have a letter to center off of and build off of that. If we were to use this Z, this Y and Z are not the same, so that wouldn't work. So what do we have to do? We have to pretend like there is some like invisible letter in between that we can use to build off of. So then Z and Z are the same, Y and Y are the same, and we go from there. Now this problem is actually very simple if you were to solve it in O to the n squared or O to the n cubed. You can just create all the possible substrings, and then from there you would check if it's a palindrome or not. But we want to aim for something a little bit more efficient, and this problem is possible to do in O to the n, linear time complexity, and that's only possible through Manacher's algorithm. And this algorithm is a little bit harder to use, and it does make it seem like a hard rated question. But let's just go through how we do that. Now the first thing we will do is, remember we just talked about the odd and even cases. How do we do that? How do we actually center this palindrome around something when nothing exists there? So the first thing we will do is actually, let's move this up here. We're going to create a new string called T. Now T will be the exact same as S, except we will have hashtags between, before, and after every single letter that is found in S. And why do we pick a hashtag? Now this hashtag can actually be any letter or any character, as long as this character won't be in any of the strings. And what we can do now is actually build the palindromes using these. So now here we could just center on the B, and this is the palindrome. We build it the exact same way, and then after all of this, we will just get rid of the hashtags in a different function. Well, not in a different function, but just a separate part of the algorithm. And here, this palindrome is actually this. And see, we are able to center it around this hashtag, and it works perfectly as long as we remember to take it out in the end. Now, so that was step number 1, to pre-process the text and create it into string T. The other thing that we will have to do to prepare for this algorithm is let's create a new array called P. And this P will store the number 0 and will be the same exact length as T, because the indexes must line up. So if we have this, now how does this array P work? This array P will store the radius of every single palindrome from its center. What does that mean? So let's look at every single palindrome. let's look, this A right here is technically a palindrome, and from A we have a radius of 1 because it goes 1 and 1. Now it will store it for every single one, but let's look at one that is a bit longer. Instead of this A, let's look at this B. This B has a longer palindrome here, and what is its radius? Its radius is 3, so we store a 3. And we're going to skip over like a lot of them, but if we go to here, this 4 has a palindrome radius of 4 with this hashtag, sorry. And you can see that from here, all we have to do is just get the biggest number, which is 4, and from there we build off of that center to give us our longest palindromic substring. It's just that simple. Now the complicated part behind this algorithm is actually how do we fill these numbers in. And to do that, let's just start off by creating a few variables. We're going to create a center variable, and this will start off at 0. Now what this will do is actually we will iterate through this through the string of characters, right? And the furthest palindrome to the right, so let's say we have these aren't actual palindromes, these are just examples. Let's say we have this palindrome and we have this palindrome. This one right here is the one that's furthest to the right. We would store this center, right? It's not an actual palindrome, and we need another right variable, which for now is 0, and this will just store the right indice of that palindrome. And let's just remove all of this. We have a right, and we'll go over what all that means once we get to it. Now what else do we need? We have a mirror variable, and we won't make it equal to anything for now. Once we get to it, I'll also talk about it. But essentially what the mirror means is, let's say this is the palindrome that we're looking at, this is the center, and we are looking at this point. The mirror of this point is just this, correct? Like according to the center, if we were to reflect off of the center. Now our I is actually just what indice we're going to be at, 0. So let's say that our I was actually here. Our mirror would end up being, well, it would be the center minus the distance to the center, which is just I minus center. And this equation just simplifies to 2 center minus I. And for now, we're just going to keep it at 0 because our center and our I starts off at 0. And I think that is pretty much it for now. Now let's start. Okay. The first step, we obviously iterate through every single one. Now we have a very first check, right? And that check is to see if this I is within the interval. And now remember, the interval, we're talking about the furthest to the right palindrome. And starting at 0, we don't actually have any palindrome on there. So, but let's just write it down. So our first check is I less than right? Because this, when we represent it, let's say we're gonna have the interval with open brackets like this, and in mathematical terms, open brackets means a non-inclusive range. What does that mean? That means that at the ends, we are not inclusive of the ends. So we are not doing I is less than or equal to right. It has to be I is less than right. And let's leave a little note. I is within interval. Okay. Now remember, this range, we're also pretending that the center is at 0, right? And we do also have a left bracket, but we don't really care about it. We never actually compare it. That's why we don't really store it anywhere. But anyways, is it within the interval? No. Now, the second step is actually to expand the palindrome. how do we do that? Well, we do that by setting a left pointer. Let's just do L and a right. And remember, these are not the same, but more importantly, left is out of the it's in the border, so it's out of the border. So automatically we know there is no palindrome there. And now the third step is check if P at I plus I is greater than right. And what is that saying? That is saying if the point at I plus the radius of its palindrome is greater than right. So we can leave a little note saying if new interval outside of old. And now we already came to the conclusion that we don't have a new palindrome. So in this case, this is false. What we could do is actually just move this all to the right, to A. Now let's just get left and right out of the way, because they aren't always started next to I. And now let's update I. And that makes our mirror equal to -1. Okay, now we do the same thing. Is I less than right? No, it's not. Now we can expand the palindrome. We have a left and we have a right. Now notice the two hashtags are the same. So what we do is actually we increment this by 1 because the palindrome actually exists. It has a radius of 1. And we move these out, and L is outside of the border. So that is it. We just move them out of the way now. And now we're done with step 2, and now we do step 3. P at I is actually this point right here. So is 1 plus 1 greater than right? Right is 0. Or in other terms, this is our new interval right here. Is it outside of our old one? Yes, it is. So now our new palindrome is actually the furthest to the right. So what we have to do is update the variables that store our old interval to become the new interval, which is P at I plus I, and the palindrome center is now different, and this becomes I. So first thing we do, change the right, and that is now equal to 1 plus 1, or it's just the palindrome right here, and we update the center. All it is for now. Move on. Our I is now equal to 2. Our mirror is now equal to 0. And that's because obviously from this point, the mirror against the center is this point, right? So that makes sense. And let's just move through this quickly now. Is I within the interval? No, it's not, because we're not including the edges. Now we expand the palindrome, but we can see that A and B are different. So already we can just say no. Now are we out of the old interval now? Well, we don't actually have a new palindrome, so that statement is false. So we could just move on to this B. So we update I is equal to 3, and this center, this mirror now is actually 2 times center, which is 2 minus I of 3, so it's back to -1. 2 times 1 is 2, minus 3 is -1. Yes. Okay. Now let's see. Is I less than right? Are we within the interval? No. Now, so that means we have to expand from here, left and right. And we see these hashtags are the same, then the A's are the same, then the hashtags are the same again, before we go out of the range. So what is the radius of that? Well, while we do that, we would have been incrementing this B value, and it becomes a value of 3. Okay, so that's step 2 done. Now, is our new interval outside of the old interval? Yes, it is, because our new interval actually looks something like this. Right? So we have to update the right to match that. We have to move this here, and we have to update our center. Okay, all good. Now we move here. Our new I is 4. We won't update mirror every single time. We'll just update it whenever we need it. Oh, we haven't been updating these. 1, 2. So our center is actually at 3. So 1, 2, 3. And our right is at 0, 1, 2, 3, 4, 5, 6. Okay, now at this new point, is it within our interval? Yes, it is. And what does that mean? This is an important step here now. It means that we don't actually have to re-expand it right away. We can just give it a minimum value at least, because we know that it has to be either p at mirror, because remember it's a palindrome, so one side has to be equal to the other, right? Or just in case that palindrome on the left side is actually bigger because it extends more to the left, it could also be the distance between right and the I value. So what does this mean? Now, remember, now let's figure out what our new mirror is. Our new mirror is 2 times center minus I, and I is 4. So our mirror is 2. So 0, 1, 2. This is our mirror, right? And that value is 0. So we're checking the minimum between 0 and I minus right, which is not I minus right, it's right minus I, which is 2, so that just has a value of 0. So we keep it at 0. And that's step 1 done. Now we can actually expand out. We have a left and a right, and they are different, so we don't even need to do that. And our third step is our new interval outside of our old one. Well, we don't have a new interval, so automatically that is false. Now we go to this A. We check the first step. Is A within the interval? Yes. Now we are going to check between the minimum of the mirror, which in this case, this is the mirror, and see now it is a value. It's 1, and I minus right in this case would be 1. So we change this value to 1. Now step number 2 is to build our palindrome from A, so left and right. But this is a wasted step, because we've already determined that the radius is at least 1. So actually we start this here and this here, and our b and x are different. So we don't even have to check them. And we move on. We don't have a, well, we do have a new interval. This new interval ends up being the radius of 1, which is this. And is it outside of our old one? No. So our third one is incorrect. Now, what do we do now? We keep going. This hashtag, is it within our new interval? No, it's actually not, because it's not inclusive. So, oh yeah, it's not. So we move on to step 2. Okay, so we have our left and right, but A and X are different. So step 2 is done. And we don't have a new interval, so step 3 is automatically done. Now we move to this X. Are we within the interval? No. We move on to step 2. Are these two the same? Yes. So we can increment this by 1. And the A and the Y are different, so we don't need to include them. Let's get rid of this. And our third step, is our new interval outside of the old one? This is our new interval. Yes. So what do we have to do? We have to move this here. And our center is now here. So we don't need to update the left, but that just makes the left here. We can get rid of everything else. Now we just continue. Hashtag, is it within our old interval? No. X and Y are different, so expanding it does nothing. There is no new interval, so we aren't outside of the old one. Move here, this Y. We aren't within the old one, but if we do expand, this hashtag and this hashtag are the same, so we update this to 1. And because we have an interval, our new one looks like this. We have to update our right, we have to update our center, and that makes our left here. Keep going. here, hashtag, we are not within the interval. Expanding it does nothing. No new interval means nothing happens. Keep going. The Z. We aren't within the interval, but expanding it does give us hashtags on either side. So we can just update this to a 1. And our new interval looks something like this. We could move this here, update the center, and that just means that the left bracket gets moved there. Okay, we're almost there. Now this is the big one here. Are we within the old interval? No. Expanding it actually gives us, well, this is the same, 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 this is the same. Yeah, so that does give us a lot. And let's count the radius. 1, 2, 3, 4. So that means that if we were updating it, this would have been a 4. And now we have to check, is our new interval outside of the old one? What does our new interval look like? It's like this. It's pretty big. Goes to here. So what do we have to do? We actually have to update this right one. We have to update the center, and that makes this left one here. Okay, now we move on. Here. Now we are within the interval again. So we're checking the minimum between the mirror point, which is this one, so 1, and the distance to the outside, which is 3. The minimum is just 1. Will actually be right minus, yeah, it'd be these two right here. 3. Yep, so this is just a 1. And now that we're here, now we can expand out. But we start our left here, we start our right here. They don't do anything because they're different, so we stop. Now we move on to this hashtag. We're still within the interval, so we go here, and no matter what the distance to this right is, we have a 0 here, so we keep it as a 0. And if we were to expand out, well, this Z and this Y are different, so we keep it as a 0. Now same thing for this Y. Y, the mirror, it has a 1, and the distance to the outside is also 1. So is it 1 or 1? It's 1. And now if we were to expand out, we have to start here and here. We are out of the border, so we're fine where we're at. Keep moving. It's hashtag. Well, we're no longer in the interval, but left and right. Notice we're out of the interval. That's all it is. We're done. Now, what do we do later? Or after, I don't know why I said later. Now we grab the maximum number within P, and we look at it and we say, oh, 4 is the maximum number. That means that the maximum palindrome is at this point, and it has a radius of 4 going in both ways, right? So we grab this radius, and we end up getting what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We get 12. So from 12, we have to go 4 this way and 4 that way. And that ends up with the palindrome of hashtag Y, hashtag Z, hashtag Z, hashtag Y, hashtag. And we just have to clean it up as a final step, and that is our final answer. And since we did iterate through every single one time, and when we did expand, right, if it was a character that wasn't already within an interval, then yes, we did expand. There was no limit to how far we could expand, but the thing is, the characters that were later on covered within this range, they were expanded a maximum of 1 time. So this total algorithm ends up being O to the N, which is very efficient. Now let's head over to Leetcode and see if we can code this up. Okay, now that we are over in Leetcode, let's do the very first step, which was to pre-process the text. And remember, we used a hashtag before and after, and now what we could do is use this function dot join, and in here we put our string, And all this does is it produces a string which has the same exact characters, but in between them is all of these, is whatever character you indicate here, and then we're setting a before and a after. Okay, now let's define our center, let's define our right, and let's create our p, and let's make this an array of zeros, but we want to multiply this by the length of t. Okay, now we for loop and iterate through every single value of t, but we just need a value of t. We'll use indices to pick up what that value is. And let's just create our mirror here. Remember, it is 2 times the center minus I. Okay, now we are checking if I is less than right. Are we within the old interval? No. So what do we, well, if we are, remember, we have to check. We have to assign py to the minimum between p of the mirror and right minus I, which is the distance to the outside. And from there, that's step number 1. Now, step number 2, we have to initialize our left and our right, which is just 1 to the left of I and 1 to the right of I. Now remember, we also have to include what if we have a radius at this point. We don't want to start our left and right where 1 after and before. We actually want to start it whatever amount the radius is after or before. And this should be a plus. And now we want to check while L is greater than or equal to 0 and R is less than the length of t. So this is checking if we've crossed the borders. Well, we want to keep going if t at L is equal to t at R. And if they are, then we want to increment p at I by 1. And we want to decrement our left to go further to the left and increment our right by 1. Okay, so that is step number 2, which is expand out the palindrome. I hope that's how you spell that. Okay. From there, we need step number 3, which is this is just, if you remember, we're checking if our new interval is within the old one. So if p of I plus I, and we don't have to check if we do have an interval or not because it'll just automatically catch those cases. So we have to reassign our right and we have to reassign our center. Okay, now at this point, after we've gone through everything, we have our our array P all filled out, and we can get the maximum length of that palindrome by getting maximum at P. Now remember, the radius is only half of it, but we actually did extend out the array with T, so this is 2 to the n plus 1 length of S. So even though the radius is half of the length of the palindrome in terms of T, it is actually the full length of the palindrome in terms of S. And from there, we can figure out our start indice to the palindrome in S. And we do that by, well, we need the index of our max length. And we need to subtract that by the actual max length. Because the index is actually the middle portion of wherever the, this is just the center of the palindrome. We need to remove the radius to get the beginning of it. And we need to do the floor division by 2 in order to go down. Instead of 2n plus 1, we go down to n, which is in terms of S, if that makes sense. And now we can actually return S from the start to start plus. Now you would think we have to multiply the radius twice in order to get to the end, because one radius gets us to the center and another one gets us to the end. But what actually happens is, because this max length is in terms of t, it's actually the full diameter of it now. And if we didn't make any spelling mistakes, this should be all good to go. Let's see. Yes, there you go. We get a very fast time. Thank you guys for watching. I hope you enjoyed, and I'll see you guys in another video.